It is almost impossible for us to have a day without seeing anything circular. There are lots of objects that facilitates this concept, and it is interesting to discover how this amazing mechanism works. Today, let us learn the basic principles of our turkey lessons, all about circular motion. First, let us talk about the main forces acting on a circular motion, the centripetal and centrifugal force. Centripetal force literally means center seeking. It is the force acting upon a circular motion towards its center or axis of rotation. It is seen in our daily lives, like for example, when we ride a roller coaster. It is the force that prevents us from falling. This is because one good nature of circular motions is that it pulls the object's inertia, which keeps it moving along a straight line, making it constantly drag towards the center. In our first experiment, let us see how centripetal force would act on a revolving jar with water. In this experiment, a rope and a cup partially filled with water is to be used. Pay attention to what would happen as the demonstrator slowly swings it first to accumulate acceleration and finally spin it multiple times. Notice that the water inside the jar remained inside. But why did it do so? This is because as the centripetal force acts, it is preventing the water to move towards her when it is at the top. Its inertia is being suspended. Now let's see its effect in a plate. As we all know, every time we toss it, it spins faster and faster until it finally stops. But why? That is because the force we exert is unequal to each of the sides. And since it is in circular form, the force circulates throughout its circumference, and the reason why its rotation becomes faster and faster until it finally stops is that because its centripetal force pulls the force inwards, making its rotation shorter and shorter. Now that we've learned what centripetal force is, let us move on to its counterpart, the centrifugal force. However, though it is termed as a force, it is really not. It is just a secondary effect of the centripetal force, and its function is to sensate the object away from the center. In our experiment, our demonstrators will testify to us how centrifugal force feels. Watch what happens as they spin around holding each other.
Hey, so how did it feel?
Man, I feel like I'm getting pulled away by him.
Yeah, totally agree with you.
That exactly is what centrifugal force is. But always remember, there are actually no force going outwards. It's just a sensation. We've learned a lot, but it's not over. Now let's talk about the tangential velocity. It is one of the velocities in a circular motion. The concept says that as the circular path moves along, the object's direction is always tangential to the circle and perpendicular to its radius. And if the centripetal force vanished, its path will still follow the tangential line from which it belonged right before the centripetal force disappearance. Watch how the object attached to the string fly off the circular path. As seen on the experiment, the object's direction as it left the circular path was not random at all. It is tangential to the circle. Now that we've learned such things, let us play with them. Explore the factors affecting the circular motion's behavior and see how they look in real life. The radius, velocity, and force.
Good day. As you can see, today I am riding a bike. Let us see how the radius of the circle I am moving on affects the way I feel the acceleration. Now let's try it for the bigger radius. As you can see, it's much easier. Now let's try using a smaller radius. I felt like I was gonna die. You know, man, it's so short, the radius is so short. I felt the acceleration was way more than the previous one.
Well, there you have it. We hope you've learned about this fancy concept and apply the things you've learned in real life. Thanks for watching.